Today we are going to graph linear equations using x and y intercepts. But before we can do that, we need to figure out what are x and y intercepts. So let's take a look at the graph that's up here in the lower or upper left area of this screen. And the y-axis is the vertical axis. So an intercept is where the line crosses the y-axis. So I look right here and I see that it crosses it right here at this number. So that number is positive 3. So this is my y-intercept. And again, you think of like a football team, when they intercept the pass, it changes possession from one team to the other. Well, this is like changing sides of the y-axis. At that point, it changes from the positive from one side of the y-axis to the other side of the y-axis. So that's why they call that the y-intercept. And here, this y-intercept is at 3. So we can write this as 0, 3. Or we could just say y equals 3. Now, it's important to understand the form of the ordered pair for the y-intercept, because the value of x is always 0 when we have a y-intercept, because we don't go over left or right, we stay right on that y-axis. And we're going to use that concept later on when we try to find y-intercepts and x-intercepts when we don't have a graph. So taking a look at the x-intercept here, it's where it crosses the x-axis. So here's the point, right there at -2. That is called our x-intercept. And again, thinking of the football correlation, they use that word because it's when it changes possession in a football game. When you intercept a pass, here the line is crossing the x-axis. Here it's on one side, here it's on the other side. And so at that point, we call the intercept. So that's the x-intercept, and that value is -2, 0. That is the x-intercept in this case, or we could say x equals -2. So again, it's where it crosses those axes are the intercepts. So x-intercept is where it crosses the x-axis. Y-intercept where it crosses the y-axis. So let's take a look at some problems that we'll end up seeing. And we'll start with this one, letter A. Let's say we had this equation, 4x plus 2y equals 16. So what we're asked to do is find the x-intercept, find the y-intercept. So remember that concept I talked about here, where if I want to find the y-intercept, my x value is 0. And so that's what we're going to do. So when we try to find the y-intercept, you're going to set x equal to 0, because looking up here, the y-intercept is when we don't go left or right, we stay right on that y-axis. So x is going to equal 0. So we go ahead and do that work. We have 4 times by 0. So we're setting x equal to 0. I put 0 in place of x, plus 2y equals 16. So what happens here is basically that 0 times that coefficient cancels out, so I'm just left with the y term. And I have that coefficient in front, which I need to get rid of, so I'm going to do a division problem here, divide by 2, and then I'm left with my y value. And so my y-intercept is y equals 8. And so when I go ahead and write the answer, I can write that in the ordered pair form. And so the ordered pair form is when x is 0, so I put in 0 for x, I got 8 for y. And so that is my answer for the y-intercept. Now let's say I want to find the x-intercept. The x-intercept, well, looking at what we have here, x-intercept is always when it crosses the x-axis. That means we do not go up, we do not go down. We stay right at 0 for y. So we are going to set y equal to 0. And so when we do that, we rewrite our equation, 4x plus, now we're going to put 0 in for y, so plus 2 times by 0 equals 16. So we go ahead and do some work there. Remember that 2 times by 0 is just going to cancel out. So all I'm left with is that coefficient of x. So I'm going to go ahead and divide by 4 here, divide by 4 on this other side, and now I'm just left with x equals 4. So when I did that division, I ended up with 4. So we can go ahead and write the answer as an ordered pair. And so remember, 4 was x when I set y equal to 0. So those are our two intercepts, the y-intercept and the x-intercept. So let's just do another problem here where we just find the x and y-intercept. We'll try one like this. Let's say a little bit tougher problem because it's got a fraction involved. 1/2 x maybe minus 2y equals 8. And so I'm going to do the same sort of thing. I'm going to find the x-intercept to start with this time instead of the y-intercept. So remember, I'm going to set y equal to 0. And then over here, I'm going to find my y-intercept. And when I find the y-intercept, I'm going to set x equal to 0. So let's see what happens when I do that. Well, when I go ahead and put in a 0 in for y, it's going to cancel out this whole term. So all I'm left with is the 1/2 x minus, and then this 2 times by 0 again, I said cancels that term out, and it equals 8. So really, since you know you're setting this y equal to 0, you don't even have to write that part down. It cancels out. Same thing on the y-intercept. If we go ahead and set x equal to 0, you have this 1/2 times 0, but you know this is going to equal 0. You know that because you're setting it equal to 0. You're setting x equal to 0. 0 times a number makes 0. So all we're left with is that negative 2y equals 8. So really, when you're doing these problems, when you set something equal to 0, it cancels out, so you're just left with the other variable. And so we go ahead and solve by doing some opposite operations here. So on this side, we're going to end up multiplying by 2 to cancel out these 2's here. Do the same thing over here, multiply this side by 2. And what we're left with is that x term, and x equals 16 is what I get. Again, I multiplied the 8 and the 2. Over on this other side, though, I need to cancel out that negative 2, so I need to divide by negative 2. So when I do that, I end up with my y value all by itself. So y equals negative 4. So I can write the answer as an ordered pair. So I'll go ahead and do that. I'll write down the value of the x-intercept is 16 when, again, x-intercepts are when y is equal to 0. Over here, y equals negative 4, but that's only when x is equal to 0, because I set x equal to 0. And so those are my two intercepts. Well, one last problem, since I got a little bit of room here. Letter C. Let's say I've got some extra terms in this problem. Maybe like 4y, then it says plus 5x, and it equals 2y, and then minus a 3x plus 16. So it looks a little bit trickier. All you want to do on this one is move the x's and y's onto one side. So all we have to do is take this 2y and bring it over to the other side. And then on the other one is the same thing. Bring that 3x back to the other side. So when we do that, what we've got left here is our 2y plus 8x equals 16. So when I go ahead and find this x-intercept, and I'm setting y equal to 0, so I'm going to cancel out this term. So all I'm going to write down is 8x equals 16. On the other side, I want to find that y-intercept. And so I know I'm going to set x equal to 0, so I don't even need to write that 8x term. It's just 2y equals 16. And so from that point, all I have to do is some opposite operations. So I'm going to divide by 8 on both sides. Here I'll divide by 2 on both sides. And it gives us our answer. X equals 2. And over on this other side, I have y equals 8. And so we've got our answers. We have 2, 0 is our x-intercept, and our y-intercept is 0, 8. And then from that point, we've got our two intercepts. So the next part is going to be dealing with graphing an equation when we've got by using the x and y intercepts.